Hello, my name is Martin Taylor. I'm Chief Technical Officer at Metaswitch Networks, and I'm here today to talk about converged broadband access, what it is, how it works, and why it matters. First, I want to say a few words about Azure for operators, and perhaps give a Metaswitch perspective on this. Our aim, simply put, is to make Azure the number one public cloud destination for telco network functions, to be the most effective public cloud environment for network functions to operate in and deliver the service that telcos need. One of the things that we've learned over many years of working with telcos and, of course, in the telco network functions space is that network functions are not like enterprise IT applications or web scale e-commerce storefronts or any of those kinds of things that we typically think of the public cloud as being the environment for. They have different requirements from the cloud. And this is something that our experience has shown the hyperscalers don't understand very well. So what Microsoft has done by acquiring Metaswitch and Affirmed is essentially to bring into the company a large number, hundreds in fact, of experienced software engineers many of whom have spent long careers working in the networking software space and delivering telco-grade network functions, and who really understand the requirements of the environment in which these functions need to run. So this is really what we mean by built on a foundation of telco DNA. Those are probably the most important words on this chart. That telco DNA brought into the Azure organization is going to give us the ability to make Azure the absolutely best place for telco network functions to run. Now, telcos obviously, have many of them already invested quite heavily in private cloud, and the question obviously arises, well, why do I care? Why do I want to run my network functions in public cloud? So to that, I think we would point out that it is really hard to build and operate private cloud successfully and to keep on evolving those environments to kind of keep pace with the software landscape. A lot of telcos have really struggled with this, and Azure, of course, has massive economies of scale on its side. And those economies of scale essentially translate into economies of operating cost. And ultimately, telcos, I think, are going to find that it's a more cost-effective place to run network functions than to build their own infrastructure for this. And by doing that, it allows telcos to focus on what's really important here. And what's really important is building and operating and differentiating the services and not worrying so much about the infrastructure. And of course, the scale of a public cloud like Azure also brings a bunch of platform tools that aren't available in a private cloud environment, like AI capability sets that telcos can leverage to better optimize the operation of their services so that they can be delivered more economically and with a higher quality of service as far as users are concerned. Now, we fully understand that not every network function will move into public cloud. A lot of them are good candidates for that, but some will likely remain in private cloud, perhaps in perpetuity. So the ability to operate seamlessly across a hybrid cloud environment is absolutely critical here, and that is very well understood in the whole Azure for Operators initiative. Monetization and the development of new revenue streams is really about innovation in services and innovation in applications that leverage service provider networks. And Azure has, the big advantage Azure brings to this picture is it's a fantastic environment in which to develop new stuff. Huge amount of platform capabilities that accelerate the development of new applications and service capabilities. And of course, it has a massive developer ecosystem already in place. So it has the potential to become the place where telco innovation is massively accelerated, and enabling some of those new revenue streams to start flowing. And finally, of course, we understand that trust is super important. Telcos, view their networks as absolutely mission critical. That's totally understood. But of course, so do many Fortune 100 companies who run mission critical applications in Azure as their favored operating environment. So to the extent that Azure is trusted by those large enterprise customers, so telcos should be able to trust Azure with the mission critical functions that make up their networks that deliver their services. Okay, now let's drill into the what, why, and how of the Converged Broadband Services Edge. So to set the scene, I want to point out that broadband today operates out of two entirely separate technology silos, wireless and wireline, respectively. So mobile broadband delivered out of an evolved packet core in the LTE generation, evolving to 5G and eventually 5G standalone packet core. Wireline broadband today is delivered out of broadband network gateways supported by AAA servers. These are two completely separate technology stacks, no overlap at all, defined by two different standards bodies, the Broadband Forum and 3GPP, respectively. Now, of course, it's worth pointing out that many operators around the world are delivering both mobile broadband and fixed wireline broadband services, typically out of separate groups, but ultimately delivering broadband to consumers, businesses, and so on through these two different stacks. And a lot of them are really interested in bringing those two together and converging the services edge. Now, there's a long list of reasons why they are interested in that, and we're going to cover that in depth in just a moment. But before I do that, let me just point out that there is, and has been for the last couple of years, a close cooperation between Broadband Forum and 3GPP, working under the heading of wireless wireline convergence. And what this work has resulted in is the definition of a new network function. This is the enabling new element, if you like, that makes wireless wireline convergence possible. It's called the access gateway function. And the standards that have emerged from this work, although not quite finished, are close enough that it's now possible to demonstrate wireless wireline convergence in action. And the first operator lab trials have already taken place, and we participated in that. And I'll say a bit more about that towards the end of the session. Okay, so let's look at the reasons why this is interesting to network operators. And the timing is important here because we're at a point where operators, having already invested substantially in virtualizing many core network functions, for example, like IMS voice, are now starting to turn their attention to planning the softwareization and virtualization of the edge of the network. That hasn't really started to happen yet. And in doing so, are looking at, well, how do we move this forward? Do we just continue to maintain two separate technology stacks and perhaps look at virtualizing and softwareizing the broadband network gateway independently of our mobile broadband? Or should we perhaps consider how these two might come together? And the list of reasons here on this chart that this is interesting, these are all things that we've actually heard from network operators. So these are not ideas that we've kind of dreamed up. These are all statements that have come from operators as to what's driving their interest. So the first thing is about having to maintain a bunch of different technologies going forward, having to maintain in perpetuity two separate technology stacks when potentially they could reduce the number of different technologies that they need to maintain in their network going forward. So that's, just a basic idea of trying to trim back, if you like, the portfolio of different technologies in the network. The second point is about how the locations in which fixed broadband and mobile broadband are being served out of are starting to come together. Historically, the fixed broadband network, the edge of that has been a lot closer to end users, typically in a bunch of central offices in any given city, whereas mobile broadband has been served out of somewhat more centralized locations. But as we move to a more distributed network, of course, control user plane separation is helping this. The desire to reduce latency at the edge in order to support edge computing, that is pushing the mobile broadband edge further out. And so more and more we expect to see the fixed broadband edge and the mobile broadband edge being co-located in the same facilities, which then raises the question, well, can we bring the technologies together as well? And of course, if you co-locate these things, then the content caches that you use to minimize backhaul bandwidth and improve the user experience are now shared between fixed and mobile broadband, and they become more efficient. And the investment that you need in cache storage is reduced because you're sharing those between the two different access types. And of course, there's a lot of focus right now on edge computing and the new applications and revenue streams that will enable. Edge computing is often very sort of heavily associated with 5G, but of course there are a bunch of edge applications, like gaming, for example, which will be accessed just as much from fixed wireline as from mobile broadband. So, the idea that both fixed and mobile broadband need access to edge computing applications is another driver for bringing them together at the edge. Fixed wireless access is also an interesting driver here. The reason for this is that 5G makes fixed wireless access a lot more interesting. So we're seeing a lot of interest in leveraging 5G, perhaps increase the demographic that we can serve with very high-speed broadband, address homes and businesses where a wireline broadband connection is less economical, maybe build out overlays in areas where we don't have a wireline assets in the ground. For whatever reason, fixed wireless access is becoming more interesting with 5G. But when you do fixed wireless access, you have an interesting problem in that the subscribers you're serving are on the fixed side and expect a certain set of service capabilities, whereas the network you're delivering them out of is a wireless network, and that tends to have a different service capability set that is suited for wireless broadband. And of course, different groups of people involved in managing them. So actually, this creates some tension. Again, if you converge all of the technologies around one single stack, then that tension tends to go away. Another reason we've heard from some operators is that they perceive that vendors are heavily focused on modernizing and applying the latest techniques to, cloud native techniques, for example, to their mobile packet core products, but the same level of investment is not visible in the wireline space, particularly around the modernization of broadband network gateways. So this is really a question of saying, well, okay, if the vendor investment is heading in the 5G core space and virtual BNGs are going to be kind of second-class citizens in this environment, then maybe the 5G core should be the kind of central technology stack around which I modernize all of my broadband access. There's a possibility also of simplifying and unifying subscriber management with a single OSS BSS solution. The 5G core potentially then becomes the single place where your subscriber credentials, policies, authentication vectors, and so on is all managed out of a single system, rather than having the two separate silos that we have today with fixed and mobile. And maybe that also makes it easier to offer services that kind of cross over between wireline and wireless, kind of hybrid services. And that leads me to the final point here, which is operators are seeing opportunities for richer service capabilities in the fixed broadband space. For example, enabling your CPE to establish multiple bearers, each of which maybe has some different QoS. That's typically not possible today with fixed wireline broadband. but it becomes easy if you have a broadband service that's based on the 5G core. We've covered the reasons why operators are interested in converging broadband access. Now let's do a bit more of a deep dive into the technology itself. Here's a picture which illustrates the non-converged situation that we have today. The top half of the chart shows the wireless broadband, and of course I'm focusing here on 5G. And the bottom half of the chart shows the wireline access being served out of the broadband network gateway, typically with authentication via a radius server. And of course, both of these networks are delivering traffic into, on the right, the data network, which effectively is the public internet in general. So in order to converge the two, essentially what we're looking for is some way of bringing the traffic from the fixed wireline broadband access network into the 5G core. And that means passing the traffic through the user plane function in the 5G core, and in some way interacting with the control plane of the 5G network in order to perform authentication and session establishment and policy and so on. So there's this box, if you like, this new box, if you like, which is shown in this chart as with three question marks, and this is the area in which the cooperation between Broadband Forum and 3GPP has been taking place. So let's look at the standards work that's been going on. Back in February this year, Broadband Forum announced a couple of new standards. The first of which is TR470. So this is the overall architecture for fixed mobile convergence around 5G. And then TR456 is the specification that defines the functional requirements for the access gateway function, this new piece of network functionality that's going to essentially glue our wireline broadband access into our 5G core. And then the complementary work that's been happening in 3GPP, 23.716 is the study document that discusses the whole question and identifies the issues that need to be addressed. And 23.316 is the normative document that specifies how wireless wireline convergence operates, and of course cross-refers to the Broadband Forum work on TR456. So this is all, very much established as of release 16 of the 3GPP standards. Okay, so the architecture that we're talking about here is one in which this access gateway function kind of acts as an adapter, if you like, from the point of view of the wireline access nodes. And here, of course, we're talking about DSLAMs and GPON OLTs and so on. It looks like a broadband network gateway with a V interface, and generally the traffic on that V interface is Q-in-Q VLAN tagged to identify the customer and the access node that it has come from. The access gateway function, from the point of view of the 5G core, looks like a G node B. So it appears to the 5G core as if it was a radio access network, and it therefore delivers traffic to the UPF over a GTP tunnel, just as a G node B would. And it also provides control plane connections into the 5G core, the N1 and N2 interfaces here, so that it looks like, again, it looks like a G node B from the point of view of the 5G core. Now, the picture here kind of implies that both wireline and wireless access actually pass through physically the same UPF. But remember, this is an architecture diagram. And actually, in reality, the characteristics of the UPF that you need for wireline broadband access is the requirements are somewhat different than for mobile broadband access in a number of ways. I mean, firstly, you need much greater capacity, perhaps an order of magnitude more capacity. But at the same time, you tend to have a much simplified set of service and policy requirements. So typically, we're not doing things like a NAT. We're not doing things like tethering detection. A lot of the fancy stuff that you do in a mobile broadband service just doesn't really apply. There are also some service requirements on the fixed side that you typically don't see on the mobile side, such as the need for framed routes. And so we'll often find that network operators will actually go and look for a best-of-breed UPF to support this converged broadband access, which is different from the UPF they select for mobile broadband. Okay, so let's just go through a number of kind of phases of evolution of this architecture. Perhaps in the initial phase, you'll see on the customer premises, we have a box called the FNRG, that's the Fixed Network Residential Gateway. That does not change at all. So the solution is completely transparent to existing installed base of customer premises equipment, residential gateways, and the wireline access nodes. But on this next chart, you can see there is envisaged an enhanced kind of CPE, what's called a 5G residential gateway. Now, this is not a device with a 5G radio in it. It is a device that is wireline broadband only, but it has a 5G UE signaling stack in it. So the N1 signaling connection extends from the customer premises right into the 5G core network. And this allows the CPE essentially to establish multiple bearers with QoS if required in order to offer richer services. So there's definitely some service upsell and incremental revenue opportunities associated with that 5G RG concept, particularly for business customers. And then on the next chart, you can then further enhance this 5G RG concept to add a 5G radio to it. So now we have a hybrid device which can access the 5G core through both a wireline access and a wireless access. And this has the benefit of obviously a higher degree of resilience, because if one or other of these networks goes down, we still have connectivity. And potentially, we can use one or other connection intelligently according to its needs to optimize the traffic flow between the customer and the core network. So that's hybrid access. Now, a final kind of twist on this architecture is that very often we find that the AGF and the UPF are located in the same physical location. And in fact, that's how I've drawn it in this picture. Now, that's not always the case. We have talked to some operators who want to deploy the AGF out in the access network. I think we've also seen some talk about the wireline access nodes actually incorporating an embedded AGF. And in those cases, you'd expect to maintain separation between AGF and UPF. But where AGF and UPF are deployed in the same physical location, it actually makes a lot of sense to combine them into a single network function. And the reason for that is, of course, one of efficiency. If we have them separate, then any packet that passes from the access network to the internet is going to be touched by two separate functions. And we're going to be doing a lot of packet processing to put packets into GGP tunnels and then take them out again. We can eliminate a lot of that work and, of course, touch packets only once by combining these two functions into a single piece of software. So this combo AGF UPF, as shown in this picture, makes an awful lot of sense. And will reduce the amount of hardware resource required to support the converged broadband access by a factor of two or maybe even a bit more here. So, given that wireline broadband tends to involve a lot of bandwidth, a lot of traffic, it makes sense to squeeze every possible efficiency out of the solution. And so this combo AGF UPF, I think, will probably be the default way in which most operators deploy a converged broadband access. Okay, so now that we've covered the architectural aspects of converged broadband access, let's talk about realizing the solution in practice. We've done a huge amount of work in this area, and there's two aspects to this, and a lot of this has to do with performance and efficiency. Fixed broadband puts a lot of stress on the service's edge, because of the sheer amount of traffic that's involved here. And of course, that's not going to go away. It'll get worse as consumers are streaming multiple 4K videos over their gigabit capable broadband connections. So having really excellent performance in the user plane components of the solution is very critical. And this is where we've done a lot of very good work. So we've talked about having the world's highest performance user plane function. That is covered in a solution brief that Intel published last year, where we showed 500 gigabits of throughput on a single 2-socket Intel server, and that's without any kind of hardware acceleration. So this is totally off-the-shelf server hardware with SRIOV NICs, but no other kind of hardware acceleration. So that's the kind of performance and efficiency that we need out of the UPF in order to make converged broadband access a cost-effective alternative to sticking with the broadband network gateways. And then, of course, there's the delivery of the AGF. This is a brand new network function. The standards actually are nearing completion. The work still continues on some of the fine detail of TR456 in Broadband Forum, but there's enough of it complete to be able to build an AGF that does the job of connecting traditional wireline broadband access nodes into a 5G core. And we have built an AGF, and we have demonstrated that in the labs with Vodafone. That was announced back in April this year. And that trial, in conjunction with our UPF, demonstrated that the hardware resources required to support a converged broadband access are no greater than you would need for a conventional virtualized broadband network gateway. So this is a solution that is cost effective, even though from an architectural standpoint, it might appear to be more complicated than staying with a BNG. And then, of course, the final key point here is that this is all delivered as software with the most up-to-date approach to a cloud-native network function design. It's packaged as containers, it's orchestrated by Kubernetes, it's deployed in an automated way with Helm, so you can deploy UPF, AGF, even all the other components of the 5G core with a one-click operation that takes a Helm chart as the template and instantiates and configures all of these elements to work together. It's a microservices architecture decomposed into individual elements that scale independently of one another. They're all elastically scalable and N+K redundant. And in the redundancy scheme and the scaling scheme is seamless from the point of view of the broadband sessions that are supported over this solution. So we can, a container can fail, and this is invisible to the users of the service. Likewise, we can move sessions around, we can dynamically scale the overall deployment, and all of that can happen without the need for a maintenance window. And of course, that applies to software upgrades as well. And as I said, no specialized hardware is required. This is off-the-shelf Intel server hardware with standard SRIOV NICs. So the overall message here is converged broadband access is real, demonstrable. It's absolutely ready for lab trial and potentially even early field trials. Okay, so to come back now to Azure for operators and kind of join up the dots with converged broadband access. I think we see a couple of stages here. We've talked about network functions moving to public cloud. Probably the first network functions that are going to head in that direction are more core functions like the packet core control plane, or the IMS, or voice messaging services, whatever. But over time, I think we're going to see Azure move towards the edge. We'll certainly see Azure move towards the edge. And in fact, of course, Azure Edge Zones and so on is addressing that very space. So we see this converged broadband access as being deployable in a couple of different ways. I mean, one is, of course, these software elements are deployable in a private telco cloud. That cloud just needs to support containers as a service, and within that, support multiple network interfaces and SRIOV. These are fairly well understood requirements for high performance network functions running in a cloud native style. But we also see AGF and UPF and the converged broadband edge running on Azure edge zones. And the vision here is for an Azure edge zone to host not only telco network functions like AGF and UPF and the whole converged broadband services edge, but also, of course, edge applications, content caching, and applications developed and delivered by third parties around IoT and gaming and video analysis and so on. So we see a coming together both of public and private cloud at the edge and fixed and mobile broadband at the edge. So it's kind of convergence in multiple dimensions, if you like. That's all I have today on the topic of converged broadband access and Azure for operators. Thank you very much for listening to this webinar. And I'm very happy to take questions by email. My email address is here on this final slide, martin.taylor@metaswitch.com. Thank you again.